Hi. So today we are going to discuss about what is called as a microgrid. So microgrid is basically a typical hybrid electric network which comprises of distributed energy resources, local loads, and energy storage systems for supplying power to specific areas or local localities. The main function is used to ensure the system stability under different fault conditions. So the microgrid plays a vital role. So as of micros, the grid structure is considered. It has been classified into three. One is called as an AC microgrid, DC microgrid, and a hybrid microgrid. So based upon the bus structure, so this has been classified. So we'll see the importance of the different types of microgrids, AC, DC, and hybrid microgrids. So this is an pictorial representation of an AC microgrid, which has an utility grid and a DC distribution transformer. The AC microgrid is both the AC bus and below the AC bus that is called as an AC loads are there. In AC microgrid, when the bus takes AC supply, it is called as an AC microgrid. When the bus takes in a DC supply, it is called as an DC microgrids. When the system has both the AC bus and DC bus, it is called as an hybrid microgrid actually. So the figure which shows here is called as an AC bus and which is called as an AC microgrid. So even though the bus is an AC bus, so we have a different source of energies are there. If we connect different source of energy, so that is called as an AC microgrid. In the system, a PV solar is there. So the output is often DC. While in case of an AC, we have a wind turbine, we have an AC source output, and EV charger, it is often DC, and battery is also DC. As the system is called as an AC microgrid, so we are converting the DC supply to AC and we are giving to the AC buses. Similarly, wind turbine, so we are converting the AC into DC and DC into AC. So for our flexibility, so we are converting so the voltages, and similarly for the EV charger and as well as for the battery. So always our utility is of an AC system, and the PCC is called as a point of common coupling. The output of the microgrids are converted into AC supply, and this is connected to the PCC, and the supply to the utility grid through the transformer is connected to the AC bus. The loads which is connected is all of in terms of an industrial loads, domestic loads. So all loads are connected, and these loads are connected in terms of AC supply. So the AC bus is connected directly to the loads. So what is the main advantages of using the AC microgrid? So it can be easily integrated into a conventional AC power system, providing more controllability and flexibility for them compared to other microgrids. So as we know, so the entire system is AC, so it is very easy for the controllability and flexibility. So AC to AC converters must be used as an interface between DC components and the AC common bus. So this decreases the total efficiency dramatically. So the next one is called as a DC microgrid. So as our utility, we know the utility and the transformers works under the AC supply. So the DC microgrid is an so when the bus takes a DC supply, it is called as a DC microgrid. Here all the DC voltages are converted and all the AC voltages are converted to DC, and the DC supply is given to the DC bus, and these DC bus is connected to the utility grid via transformer through the DC to AC converter, and the loads which we are utilizing is all of an AC. So we are converting the DC into AC through the converters, and the power are utilized. So what are the advantages and disadvantages of using a DC microgrid? So they are connected to the main grid through AC to DC, as we have been discussed. Compared to AC microgrid, DC microgrid provides reduced power conversion losses since very few power conversion stages are needed, resulting in higher efficiency, lower losses, low cost, and smaller size. It provides better stability than AC. since no reactive power exists in DC microgrid. As we know, so there is no reactive power in DC, so the loss is very minimum. So they are better option for DER integration. The most popular structure are bipolar, unipolar, and then homopolar. So the next structure is called as a hybrid microgrid. So which has an both AC bus and DC bus. So these AC and DC buses are connected to an hub bus, and through the that is DC bus is connected to the main bus through the DC to AC converter, and this is connected to the utility grid via the distribution transformer. Here we have two buses and based upon our requirement, so we can able to give the input supply as well as we can take the loads accordingly. So here very fewer conversion stages. So decreased here also we have a decreased power losses, lower overall cost and high reliability. So what are the components which the distribution in the microgrid which I have is an distributed energy resources. So in general it is called as an DR. So it consists of a solar PV, wind turbine, diesel generator and fuel cells, which is used for generation of power in local energy storage system. So the mainly it is often batteries, flywheel and supercapacitor. And so it stores excess energy and supplies during the demand period. The next component is called as an power electronic converters. So the major components are called as an inverters, rectifiers, and DC to DC converter, which is used to control the voltage, frequency, and power flow. The loads are residential loads, commercial loads, industrial loads. So it may be classified as a critical and non-critical loads. If it is of an hospital site, so it is called as a critical load. So if it is of a residential, it is called as a non-critical load. So it has been classified based upon the need. So the power utilization would be different. In terms of a control system, so there are different types of control systems, centralized and decentralized control. So which is used to maintain power balance and ensures voltage and frequency stability. Protection systems. So we know about the major protection systems in the electrical network systems are called as relay circuit breakers, which is used to detect the fault. So prevent damage and isolates the fault. So the communication systems are very much most important for a microgrid system. So it has been classified as an wired and wireless communication. It enables the monitoring and coordination, supports real-time control. We know about the point of common coupling. It is a connection to the main grid and it enables grid connected and islanded operation can also be done. So the key advantages of microgrids are it is a highly reliable, operates in islanded mode. So we can operate the system under an islanded mode. We can connect if any fault occurs in the utility side. So we can disconnect the PCC point and we can operate it as an islanded mode. And it supplies uninterrupted power, supplies critical loads, and faster fault isolation can also be done. Microgrid operation so works with or without main grid. So uses local generation and storage. Smart control ensures stability. Conventional grid limitations fully dependent on central grid. Large scale outage during faults. Slow restoration time. So this is a conventional grid. So it is depend only on the central grid, and the restoration time is very low. Large scale outage would be happen during the fault. So, compared to the microgrid and conventional grid, so microgrid is a highly reliable. It is a localized faults, so renewable is friendly. While in terms of unconventional, it is a lower reliable, wide outages, less flexible. So some of the limitations of using microgrid is in high initial cost, so expensive installation, distributed energy resources, storage and converters. It is a highly cost during the first investment. So next one is a complex control system. So advanced control is required. Voltage and frequency balancing is very difficult and needs smart controller for this. So protection challenges as the microgrid is often a bidirectional flow of power. So a difficult fault detection and traditional protection is not suitable. Limited power capacity suitable for small areas, not for a large scale demand. So energy storage dependency, batteries are costly, limited lifespan, performance depends on storage. And maintenance is two most important, multiple components, skilled personnel is required and high maintenance is required. So as of using the DERs, so power quality issues is a major one because we are using a number of power alternating devices. So harmonics plays a major role and voltage fluctuations would be there, need filters and control. All the things for a betterment of the power. So regulatory issues plays a vital role. So government has initiating many regulatories and policies for grid integrations. Uh, some of the standards are IEEE 519, IEEE 1547. So these are some of the regulatory standards which is given for distributed energy resources. So while in conclusion, so microgrid ensures a continuous and reliable power supply even during grid failures, making it superior to conventional grid. So thank you all for patient listening of the introduction about the microgrid.